can you solve this system of equations? Feel free to pause the video and give it a shot. And keep watching to see the solution. Okay, so we've got logarithms in the exponents here. And that complicates things. We want to make things simpler and get rid of them. And one way we can do that, one way we can move them away from the exponents is to take log base 2 of both sides of this equation. That way we can move this over here. Then we don't have logarithms in the exponents. So yeah, I can move this here, and it's going to become log base 2 of y times z times log base 2 of x. And then the right hand side, we can split this up because we're multiplying here. So we'll split it up as log base 2 of 2 to the power of 8 plus log base 2 of 3 to the power of 4. Okay, and how do we simplify this and this? Well, I'm going to copy the left-hand side again. Left-hand side remains unchanged, but this is just 8 because I see a 2 here and 2 here, and then this is just 4 log base 2 of 3. Just move this here. And okay, let's go ahead and do this with the second and third equation. So what does the second equation become? So the second equation, it becomes log base 2 of this, so zx times log base 2 of this, y, because the x was here, so the y is here, and then the yz was here, so the zx is here. Okay, and then this is going to be 9 plus 6 log base 2 of 3. And then the third equation is going to be, it's going to be this. 5 and then 10 log base 2 of 3. Okay. We still have logarithms, but they're not in the exponents anymore. So it's a little simpler, but I think we can get rid of them completely. Yeah, I just don't like working with logarithms with systems of equations at the same time. It just complicates things. So I'm going to let a be equal to log base 2 of x, b be equal to log base 2 of y, and c be equal to log base 2 of z. Okay, so how do I express this in terms of a, b, and c? So this is going to be b plus c. So if I add this and this, I'm going to get this. Times, well, this is just a, is equal to 8 plus 4. I'm just going to let this be equal to k. And then what does this become? It's going to become c plus a times b. Cool. And then this one is a plus b times c is equal to 5 plus 10k. Nice. Okay. I'm going to get another sheet of paper. Okay. Let's go ahead and get rid of the parentheses here. So AB plus CA is equal to 8 plus 4K. And then BC plus AB is equal to 9 plus 6k, and then CA plus BC is equal to 5 plus 10k. Okay, and let's go ahead and add all these three equations together, because, well, this is a new system of equations. We have three unknowns, this, this, and this. And if we add them together, it's just a strategy to eliminate variables when you're presented with a system of equations that looks like this, and the right hand side are all constants. So let's go ahead and add them. 2 times AB plus BC plus CA. You'll see what I mean in a second. This plus this is 22. Oh, shoot. Nah, it's allergy season. Okay, let's divide both sides by 2. Cool. And now that we have this, we can subtract this from this, and we'll end up getting BC by itself. So let's do that. And then we need to do this minus this. So 11 minus 8 is 3, and then 10k minus 4k is 6k. Okay. Let's see here. How about I subtract this one from here? What do I get? I get CA is equal to 11 minus 9 is 2 plus 4k. And then subtracting this from this, that's going to give AB is equal to 6. Yeah, just 6. Okay, this is simpler than this, the new system. And then we're gonna apply a similar strategy like we did just now. We're gonna multiply all these equations together. So we're gonna get a squared b squared c squared is equal to, okay, before I multiply all these on the right hand side, I should probably factor. It'll make multiplying a little bit more, a little easier. So this times this, that's 6 squared. This times this is 1 plus 2k squared. Okay, and let's take the square root of both sides of the equation. So that gives us plus or minus 6 times 1 plus 2k. All right, I'm gonna move this up. Cool. So now that we know this, we know ABC, we can divide this from here to get A. So, but we have two cases. So either ABC is equal to negative 6 times 1 plus 2k, or ABC is equal to positive, so just 6 times 1 plus 2k. Okay, so let's do the first case. So let's divide this equation and this equation. So it's going to give us A on the left-hand side. What does it give us on the right-hand side? It's going to give negative 2. Okay, and then B is going to be what? B is going to be, yeah, because this divided by this is B. B is going to be negative 3, because this divided by this. And then C is going to be negative 1 plus 2k, because this divided by this. And then here it's going to be A equals 2, B equals 3, C equals 1 plus 2k. So basically the negatives of these guys here. Okay. So what are we looking for again? We want to find the minimum value of x, y, z. So we need to remember what A, B, and C were when we assigned the variables. I'm going to get another sheet of paper. Okay, so remember that A was log base 2 of x, B was log base 2 of y, and c was log base 2 of z. So since we're looking for the minimum value of x, y, z, what should we do with a, b, and c to create an expression that has x, y, z? Yeah, to create an expression that has x, y, z, let's add a, b, c. So that means we have to add the right-hand sides as well. And since we're adding logarithms, we can rewrite it like this. Okay. So there are two possible values for a plus b plus c. So we can either get them from here, a plus b plus c would be all of these added together, or we can get them from here, so it'd be all of these added together. So this plus this plus this, that's going to be -6 and then minus 2k. So that's one possibility. And this one, the other possibility is 6 plus 2k. Okay, so either -6 minus 2k is equal to log base 2 of x, y, z, or 6 plus 2k is equal to log base 2 of x, y, z. Let's convert these equations to exponential form. So it's going to give 2 to the power of -6 minus 2k is equal to x, y, z. Or we can have this. Okay, and k was how much again? So we said we were going to let k be log base 2 of 3. Okay, so times log base 2 of 3 is equal to x, y, z. Here we're just going to plug that in. Okay, so which one of these is smaller? It's going to be this one. And yeah, another way I can write this is 1 over 2 to the power of 6 plus 2 log base 2, 3. So that's the same thing as 1 over 2 to the power of 6 times 2 to the power of, I can write it like this. So 1 over 64 times, I see a 2 here and a 2 here. So this is just going to be 3, the expression inside of the parentheses. So times 3 squared. This is your answer.